In this 3 steps to sketch, we're going to graph a basic cotangent graph, y equals 2 cotangent of x over 4. So let's jump right in. Here's our outline and our grid. Brief overview of the steps. Step 1 is to find and analyze all of the essential information. Step 2 is to plot one cycle of our base pattern, and in step 3 we sketch in the graph and repeat. So looking at this equation, we should recognize it to be a basic or unshifted cotangent graph because it follows pretty closely the form y equals a cotangent of bx. If you want to rewrite this equation so that the b term is clearly separated from the x, that may help you. So we would write it as 2 cotangent of 1/4 x. You may not need to do that, but just a helpful tip. So let's dive right into step 1. Let's identify a and b first. So we see a is the leading coefficient. In this case, that's a 2. That's going to help us set the y coordinates of our curve shaping points in the second step. So we'll come back to that. B we see is the coefficient of x, and that's what we pulled out right there in our rewrite. So 1/4. All right, that tells us that we should have 1/4 of a cycle of our graph happening between 0 and pi. And it also is how we calculate the period or the length of one horizontal cycle. And so for cotangent graphs, you do that using the formula pi divided by b. So pi divided by 1/4 is actually going to be 4 pi. Write that out if you need to. Pi divided by 4, 1/4 is actually pi times the reciprocal. And that's how we get 4 pi. All right, so now we're going to choose how to label our axes. And I like to be intentional for the horizontal axis. We know that our base pattern in the second step has 4 key components. So I like to take the period and divide by 4 and use that value to count the horizontal axis tick marks. And that ensures that each key feature aligns nicely with a horizontal tick mark. So take 4 pi divided by 4. We'll count by pi on the horizontal axis. For our vertical axis, 1 usually works well. Take a quick look at A. That seems to make sense in terms of counting y coordinates for curve setting points. So let's go ahead and label. Horizontal axis first, counting by pi is easy enough. We have 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. And of course you could keep going, but we'll work with the grid we have here. Go in the negative direction as well. All the same values, just negative. And then we'll label our vertical axis counting by 1. So 1, 2, 3, and -1, -2, -3. All right, we're all set up with our grid here. The last thing to do in step 1 is to find the asymptote generating equation. So if you're a formula person, you can use the formula. We kind of derived this from our parent cotangent equation or graph, y equals cotangent x. We know our first asymptote happens on the y-axis, so at x equals 0. And then the asymptotes continue to happen once a period. So we represent that in an equation by pi over b, and then k, where k is an integer, and depending on what integer you substitute in, you'll get a different asymptote along the graph. So let's do this for our equation. We have x equals 0 plus our period, or pi over b, so that we said that was 4 pi, k. So go ahead and substitute in some values for k. The whole point of finding this asymptote generating equation at the beginning is to help you confirm or double check as you are creating your graph in future steps. So we see if you let k equal 0, of course we would have our first asymptote at x equals 0. If you let k equal 1, you see you'll have an asymptote at 4 pi. If you let k be 2, there should be one out there at 8 pi, k -1, -4 pi. So hopefully that helps you see how this asymptote generating equation works. All right, now we're ready for step 2. Let's plot our base pattern. So the base pattern for cotangent graphs works like this. We have asymptote, curve shaping point, 0 or x-intercept, and then curve shaping point. Remember, a general cotangent graph looks like this. All right, so let's plot one cycle of our base pattern. Starting on the y-axis, this asymptote, x equals 0. Okay, so then you would have a curve shaping point Remember, we designed our horizontal axis scale intentionally so that every feature aligns with a horizontal tick mark. So this first curve shaping point happens at pi, and to get the y-coordinate, simply look at the value for a. So our point will happen at pi, comma 2. Okay, the next point, the 0, or the x-intercept, will happen at the second horizontal tick mark, moving to the right. So we have an x-intercept at 2 pi. And our final point in the base pattern happens at the third horizontal tick mark to the right, so at 3 pi. And this time, to get the y-coordinate, just take the value of a, but opposite, so -2. So it's our lower curve shaping point. And you've got your base pattern. Nice and easy. You did all the hard work in step 1. Step 3, I think, is even easier. We just need to sketch in this cotangent curve and then repeat it for as many cycles as we want. So sketching in a nice cotangent curve here. And you've got one cycle of y equals 2 cotangent x over 4. The repeat, super easy. All we do is redo this pattern over and over and over again. That's the great thing about trig graphs. They are repetitive, cyclic. So we just start out with an asymptote. Here's that one at 4 pi that we predicted with our asymptotes equation. We said when k was 1, we should get this asymptote. We'd have a curve shaping point. You can anticipate we'd have another x-intercept there at 6 pi. Okay, and we'll just sketch to show we know this graph continues off of our grid. All right, let's work the pattern backward in the negative direction. So we have that lower curve shaping point, 0, upper curve shaping point, asymptote. And if you wanted to, you could always just move 4 tick marks to the left and then work the pattern in the forward direction. It's whatever works best for you. So sketch in that curve. And we could work just a little bit more. You see you'd have another 0 at -6 pi and show that that graph continues on. So here we have about 3 cycles of our graph. Hopefully this helps you feel really confident in applying this method to this equation, but also extending it to any other unshifted cotangent graph. I'll put a lot more worked examples with links in the video description, so be sure to check those out. One final thing, let's look at B. I always like to do this. We said B is 1/4. 1/4 of a cycle should happen between 0 and pi, and it's kind of cool to see that here. So 1/4 of our green curve, this space right here between 0 and pi, has happened. And so that's just one more way to double check that your graph is accurate. All right, like I said, hope this helped. I'll also post graphing help for all the other trig functions. So be sure to check those links out as well. Thanks for watching.